Some of the deficiencies of this intersection right here, which some of you are aware of, but I'm just going to go through. It's on State Route 67 and Highland Valley Road and Dye Road. So we actually visited the site January 30th, and as we're coming, basically we're heading north on 67. I know there's not a north arrow, but as we're heading this way, this horizontal curve right here, the queuing actually backs up beyond that. So as I was coming down, it's kind of blind as you're coming to it. So it's like a lot of brake lights and all of a sudden you're at a quick stop, and that's a 55-mile-an-hour road. So that's one of the deficiencies. Some of the other ones are just general pedestrian access. So our goals of the project are going to be to improve the queuing and delay times, provide access for all users while keeping the Ramona culture with the horse trails intact, and we're adding a horse trail that Mario will get into, and then we have we're updating the drainage system to the current 100-year storm event.
So as Nick was explaining, we visited the site in January, and then we did PM counts in January to determine the traffic flow. We also used intersecting counts from Linscott, Law, and Greenspan from 2007 and used those counts to kind of project what the present year would be throughout the entire year, and then what it would be for 2035 and 2050. So taking those counts, we used ADT volumes also to predict what each time frame would kind of be like, so that we could determine the level of service and kind of what the delays would be like in the queuing. The queue lengths we obtained from a traffic software. The name of the software is Traffic, is version 8.0. And the ADT counts we took from Sandike Series 11 traffic forecast. We then used Synchro, which you see there, to perform a traffic analysis and based those results off of the highway capacity manual in 2010. So what we were looking for more than the actual level of service was differences in delay. So we were focused more on helping the queuing reduce and helping the delay go down, as opposed to actually seeing the level of service and trying to lower that.
This is our video. This is just a recording of the traffic simulation going on. As you can see here, this is the queuing that was going on Highland Valley Road, and it backs up all the way over here. But as you can see with the roundabout in there, with the current existing traffic volumes, there is no queuing back up on any leg or any approach. This is just the existing PM conditions, but it is the same for all conditions for 2035 AM PM and 2050 AM PM. Now I'd like to go through the design itself. If you look through the third sheet, as you can see, our design consists of a 2-lane roundabout. The inner lane is 15 feet wide, while the outer lane is 17 feet wide, and we have an 8 feet wide truck apron. The way that we came up with this design is an iterative process. We use a program on AutoCAD called AutoTurn. State Route 67 is a truck route, so we wanted to make sure that trucks are able to traverse this roundabout safely and effectively. With our design, WB 65 is able to traverse the outer lane, and with the 15 feet wide on the inner lane, it's able to traverse it with the back tire riding on the truck apron. If you turn the page, it's the 67 North approach, and as you can see, about 700 feet from the approach, a stripe median starts, and it starts to deflect the traffic to the right. And at 600 feet, the splitter island starts, and the reason why it deflects it from the center line is to slow the traffic down from speed limit of 55 miles per hour to the roundabout circulatory speed of 30 miles per hour. We use the NCHRP design manual for roundabouts in order to come up with this design. It was recommended that traffic be deflected up to 18 to 20 feet from the center line, and that's how we came up with this curve. In addition, The traffic lanes constrict down to from 12 feet to 11 feet in order to, again, slow the traffic down. We did the same thing for the southbound traffic. As you can see, it curves to the left. We didn't do the same thing for Dye and Highland. The reason for that being there's a curve right before the Highland approach. So we felt that traffic would already be slowed down from that. And same thing from Dye, it is a shorter, more residential road. As you can see on all the legs, we provided a crosswalk. And within the splitter islands, there is a pedestrian refuge. The reasoning for that is for pedestrians, they only have to cross one direction of traffic at a time. Another design feature that we have is prior to the entrance of the roundabouts and the exits, we're going to provide bicycle ramps. The reasoning for that is according to the regional transportation plan, the State Route 67 is scheduled to be a share the road corridor. So our plan is for cyclists to be able to get up onto the sidewalk so that they don't have to ride along the vehicles as they are going around the roundabout, and they can use the crosswalks to go whichever direction that they please. And that's the same for all legs of the roundabout. There's going to be ramps so that they can get on the sidewalk. And the sidewalk, we have designed it to be 10 feet wide. We wanted there to be enough room for pedestrians, cyclists, as well as equestrians. At the end extents of the roundabout, we have designed it to taper back to existing conditions so that there doesn't have to be improvements along all legs. It works with the existing facilities.
So if you would please turn to Appendix F of the binder. I obtained traffic index values and California R values of the native soil from Caltrans because they already have a project that they are planning to start pretty soon on this same intersection to alleviate the queuing problems. And then I used the highway design manual to adequately design the pavement. I didn't feel like the necessity to use treated permeable bases was necessary because the existing native soil is not really prone to saturation because of the deep water table depths, and there will probably not be any issues with that. So the pavement thicknesses were calculated using the gravel equivalent method, and we plan to adopt 6 inches of AC and 9 inches of Class 2 aggregate base on Highland and Dye, and then 8 inches of AC and then 11 inches of Class 2 AB on the SR 67 northbound and southbound legs, as well as the traffic circle portion. The sloping for the drainage, standard cross slopes were used for the design, which is 2% according to Highway Design Manual.
The manual used as reference was the County of San Diego Hydrology Manual. And the first step that I did was found the drainage area of the project location based on USGS maps. The area was divided into 4 sub-areas based on topography, land use, or soil type. Due to the small areas, the rational method was selected to find the peak discharge of each quadrant. As reference, the quadrants were labeled, the sub-areas were labeled quadrants 1, 2, 3, and 4. I used the 100-year frequency event. From the flow lines, you could see that the stormwater is flowing from quadrant 3 into quadrant 2, from there into quadrant 1, and then from quadrant 4 into quadrant 1. The drainage design that was existing was 2 24-inch CMP pipes. There was also a box culvert on Highland Valley Road. For the proposed drainage system, dike breaks with the spillways will still exist on each end of the pipes. However, changed with reinforced concrete pipes, 24-inch. The box culvert will remain in the same location on Highland Valley Road with the same dimensions, but extended to meet the road widening. For this project was designed to promote passage safely for pedestrians and vehicular traffic, to maintain public safety.
I will be discussing the biological impacts of this project on the wildlife that is existing. So if you would please turn to Appendix D. In order to obtain information on the wildlife existing that are currently in the area, I used the County of San Diego GIS system as well as the Multiple Species Conservation Program. And then I included in the attachments a map that outlines what species are in the area. So for this project, we have determined that there will be no significant impact on any floral or faunal species in the area. There will be no wildlife hazards yet, and so the project can be considered for a categorical exclusion for either CEQA or NEPA, and possibly the FHWA guidelines as well.
What really dictated our phasing for this is the fact that we want to be able to keep traffic moving no matter what. We don't want to close any roads, and we don't want to delay more than we have to. And on the plan sheets, I believe page 10 is the first phase. We are moving from the northern section of the site and essentially going around in clockwise motion, phase 1 being what you see here, and 2, 3, and 4 all going in a, counterclockwise direction. And this is actually a 5-phase project, but what we plan to do by the end of phase 4 is remove the traffic signals and actually begin the roundabout as a 1-lane. So our main concern, of course, we're getting traffic flow through the construction site and through the intersection. And one of the main requirements that we wanted to maintain was the fact that 12-foot lanes needed to exist no matter what. The scheduling for this, we used Primavera, all 5 phases listed on there. So what we did with the scheduling is pretty much listed from 1 to 5 how long it's going to take, which I believe ended up, if we started in June this month, ends in October.
So then the cost tab, which is still in the construction. So the right-of-way exhibit is right there. That's the right-of-way that we need to obtain. I know that I spoke with Sandy about getting slope easements and things of that nature. I kind of just included it all in the right-of-way acquisition. So basically that right there, we're gonna get that parcel, which you can see in, if we go back to the aerial view, our roundabout goes right over this gentleman's house. So we looked it up on a couple different websites, just real estate websites, and the property was actually sold for $879,000. So we just used that to acquire that entire parcel. And in order to reduce some of our other costs for temporary construction easements, we actually put the construction yard and then kind of a resident engineer office and a contractor's trailer within that. And it kind of all fit within there. So then going to the construction costs, that was about $5.2 million. So the overall cost of this whole project would be roughly $6.2 million, $6.3 million. Our overall goals, we believe we met. which was just to reduce the queuing and the delay times, and then provide access and still keep the Ramona culture with the horse trail and improve the drainage to 100 years from now.